Kia ora everyone, thanks for coming to my talk. My name's Daniel Veza, and today I'm talking about taking search from keywords to context with semantic search and retrieval-augmented generation with OpenSearch. It's a very long title. Like I said, my name's Daniel Veza, and I work at PreviousNext as a developer. I've been using Drupal since around 2014, and I'm one of the layout builder maintainers in core. The slides for this talk will be on my GitHub later, and they'll be available at this URL, which I've just realized you can't see. So they'll be at my GitHub. If you want to check it out later, please do. There's some code at the end that's quite helpful to copy and paste rather than try write down. I don't really use socials, but my username on Drupal Slack is Daniel Veza, very original. I mainly hang out on the Drupal NZ channel, and what happens to me during these talks is that I think about a whole bunch of questions when I leave the room. So if you're like me and that happens to you, just please feel free to come and reach out. I'm here today and tomorrow. The talk's going to be split into two sections. The first section will be kind of an overview of what semantic search and RAG is, and the second will be some code examples to kind of actually get this thing running. So, have you ever searched for something and just gotten nothing? You've built something, a knowledge base, a documentation site, an internal tool, a full-blown website. The user goes to search for something like, how do I cancel my subscription? And they get nothing. Or even worse, they just get a whole bunch of unrelated results. The answer is there. It's just titled Managing Your Billing Preferences. The title of this talk is From Keywords to Context. Historically, when we've thought about search, we've thought about it as a keyword matching exercise. A user types in some words, the search engine then looks for those words and returns the content. But today, especially in the growth of AI, that's not really how people are thinking when they're using search. They're more trying to ask questions. They think in terms of meaning, not just the exact words they're typing. They want answers, not just a page of links they have to wade through. So today we're going to explore how OpenSearch's semantic search can help us bridge that gap, moving from matching keywords to actually understanding the context and the intent behind the user's query. Traditional search, including OpenSearch's default behavior, matches the words or the phrases in your query against your documents. It ranks results by word frequency and by rarity across your index. It uses this ranking, along with some black magic in the middle that I don't really understand, to create a score for each item, and then it returns the results ordered by the score. If a user types affordable options, but your content says cost-effective plans, keyword search sees no overlap. There's no match in those words. The content exists and the answer is right there. But search just can't make that connection. For the developers and the content administrators in the room, you've probably tried to paper over this with things like synonym lists or query boosting for particular words. It does work to a point, but it's brittle. It requires constant maintenance when things change. I've seen instances where people have boost words and one piece of content they want to boost, it higher for the word query. But then another page comes along and they want it to rank higher, so they put query in there twice. And then all of a sudden it's just this fight. It just can't handle the open-ended questions that users are actually asking today. For the demonstration, I've set up a site with about 300 different supermarket items. The users typed in fruit from the USA. And we see with traditional search that the results aren't too bad, at least at the beginning. If we look at the first 4 results, we can see fruit. It all looks pretty related. Fruit is either in the title or in the description. But then we get razors. It's not quite what the user's looking for, I can imagine. So something's gone wrong there. Probably what's happened is the razor page contains the word USA a whole bunch. They're razors from the USA, maybe. So the word USA exists. The user has searched for USA, That must be what the user's looking for, right? It makes sense. So now I've got the same site, same product list, and the same query, but I'm using semantic search with OpenSearch. Razors, cookies, cheese, those things are all gone. Now we're seeing fruit, or at least close enough to that kind of result. The query and then the results have both been run through a model, so they understand the context and the intent behind the search. They're not just matching keywords. So how does this actually work? The starting point is your content, which might be support documentation, knowledge base articles, PDFs, anything that your users need to be able to actually search across. The only real requirement is that it's text. If it lives in your CMS, your database, or your file system, it can be in text. For most organizations, this content already exists. It just needs to get into OpenSearch in the right shape. Semantic search takes a fundamentally different approach from traditional search. Instead of looking for matching words, it looks for matching meaning. The basis is that you can take any piece of text, a word, a sentence, or a whole paragraph, and represent that as a list of numbers, which is called an embedding. These are generated by a machine learning model that's been trained on vast amounts of text. The insight is that texts with similar meaning end up with similar numbers, and they end up close together in what's called a vector space. I like to think of it like a map. If we look at dog-friendly hotel and we look at pet-friendly lodging, those are pretty similar terms, so they've ended up in the same neighbourhood. But if we look at, in the same neighbourhood, so therefore, if you look at the numbers, they're quite similar. But if you look at reset password, completely different, no different meaning, so they've ended up in a separate neighbourhood. They've got quite different numbers. When a user asks a question or does a search, we convert that query into the same kind of these map coordinates, and then we find the documents that are nearest to it. It's called similar neighbours. This doesn't really matter anymore if they share a single word or if they don't share a single word. This is how we get from I forgot my password to resetting my credentials. They're the same neighbourhood on that map. Now, two things happen to your content before it gets stored. First, it gets chunked, which breaks the entire thing into focused passages, rather than being stored as one giant document. It's kind of like breaking a textbook up into individual topics, rather than trying to search the entire thing at once. And then these chunks get embedded, which is converted into these type of numbers by the model. These numbers capture the meaning of the words in a way that's mathematically comparable to any query that the user might type in. At the end of this step, every piece of your content has a meaning fingerprint, and that's what gets stored in OpenSearch alongside the original text. What you get on the other side is a search index that actually understands meaning. It means a user can type in a question in natural language in their own words. OpenSearch converts what they've just searched for into the same kind of fingerprint we saw before, and finds the stored chunks that are closest to it. The output isn't just a list of pages that are sorted by a keyword frequency anymore. It's the most semantically relevant passages from across your entire content library, ranked by how closely they match the intent of the question. So we have our relevant results. We can move on to the next step, which is feeding those questions into a RAG processor. RAG stands for Retrieval-Augmented Generation, and it essentially works in those three steps. The first step is to retrieve. The user's query is converted into that embedding, and the relevant chunks are pulled from OpenSearch. We then augment. The chunks that we've been given are fed into a prompt. For example, as an academic professional, answer this question in a friendly tone. For a university client that I built a proof of concept for, we had a 16-step prompt that handled the role, the tone, the format, and even how to handle uncertainty or follow-up questions. The key is that the prompt is designed to guide the model to produce the kind of answer that you want for your users. And the last step is generate. The prompt that you've done, along with those answers, they go into a LLM, which reads the retrieved content and writes a clear, concise answer in plain language, exactly how you've defined in your prompt. The user gets direct answers that's been grounded in your content, not AI hallucinations, or a list of links that they just have to wade through and find the answer for themselves. This probably looks pretty similar to what you've probably seen just whenever you do a Google search these days. Google AI is doing their own version of RAG search, and this shows a very simple example. So the user has now searched for fruits from from Australia, and I think it actually says fruits from Australia, but that's managed to be fine. Which is a natural kind of non-specific query. Instead of just returning a basic list, RAG has retrieved that data and generated a clean, structured summary grounded in the real data from your content and from your index. So it's accurate, assuming your content's accurate. It's also improved the experience by summarizing the results and suggesting follow-up answers or follow-up queries to the search, which just continues to guide the user forward. Rather than just search results, you're getting something closer to an answer. RAG turns search into something far more useful and intuitive. And these days, with how AI is working and how things are growing, if your search is poor, users are just going to go ask ChatGPT, or they're going to go ask Google AI, and you can't really control what Google AI is going to say. It could say anything. At least this way, the answers, it's grounded in your content. You can control the prompt. You have a bit more just control over the whole process. Another quick example, but with a different intent. This one is healthy snacks. Instead of raw search results again, the system's retrieved relevant product and turned them into a clear, readable summary with things like price and origin. That's what I asked it to do in my prompt. Why I gave a second example here is I wanted to just really highlight the interpretation and the intent behind it. Fruits from Australia was kind of a clear parameter from Australia. It had a very clear filter. Healthy snacks isn't as clear. It's a bit more of a loose term than that. But the system still returns sensible options like wholemeal bread or trail mix. It also adds value by grouping everything together into a simple recommendation rather than making the user piece things together themselves. And just like before, I've asked it to suggest follow-up questions, which it's decided has been gluten-free or vegan or low-calorie options. Those can all fit in that same healthy filter. It helps to guide the user deeper. So again, RAG doesn't just return data, it understands the actual intent and delivers usable answers. This type of search summary is kind of the most obvious use case for RAG, but it can be useful anywhere that you need to summarize information across multiple documents. For example, summarize all support tickets raised this month. RAG can retrieve all of the support tickets raised in the last month and produce a coherent summary. Or surface recurring topics or concerns across a large corpus. That way, you don't need to surface through everything and try and find these connections between things. The models can do it for you and give you a summary of potential issues that keep coming up or reoccurring themes. Instead of 20 results, there's so much of a reduction in information overload. You get one answer, the sources can be shown underneath it, and all of it stays indexed in your grounded, all of it stays grounded in your indexed content. So the basic flow is that we've gone from just matching words to understanding meaning, from returning links to returning answers. Semantic search closes that gap, and then RAG closes the gap between just those results and actual understanding. Together, search starts to feel less like a query box that you're just typing into and more like asking a knowledgeable colleague. So we've gone over the why. We can now go over the how. So we're going to go through some steps to actually get this running in OpenSearch. It's going to be just some screenshots of code because I'm not brave enough to run live demos like other people are. And I am about to show a lot of code, so non-devs in the room, if I see your eyes glazing over, I don't blame you. I'll try and make this brief. Some assumptions before we get started going through this code. This works with OpenSearch 3.x or higher, and you'll need to be able to run curl commands against it. For our setup, we've used AWS Bedrock, so you'll need to have the permission set up there as well. I wanted to highlight these steps of the code because it took me a long time to get it running, and it's quite complex to actually figure out all the different things that you need to do. And all of these slides, like I said, they'll be on my GitHub later with copy and pastable examples. So again, there'll be a lot of code. Don't worry about writing it or trying to do anything like that or take pictures of everything to type out later. They'll be there. So to start, we configure the machine learning settings. We tell it to only run models on dedicated nodes. We set a high memory threshold so models don't get killed. And enable auto redeploy so it survives restarts. Model groups are an organizational concept in OpenSearch, and they basically work exactly what they sound like. They group models together. It's not too complex. We'll create them for all of our Bedrock models and save the Bedrock ID for later. We set up a connector for our first generative LLM. This is the model that will produce answers in the RAG pipeline. We use Amazon Nova Lite. That's kind of an all-purpose model. It's probably not the best at any one particular thing, but it handles everything that you need across image vision or generating answers or understanding answers. It kind of does everything really well. I'm sure if you were doing something super specific and academic or scientific, there'd be a different model you could use. But if you're not sure, Nova Lite's a really good one to start with. We deploy that LLM. The deploy flag means OpenSearch makes this immediately available. Deploying in this case just means that OpenSearch has set up the proxy for us to use. Run a quick sanity check. We send just a simple hello to verify that it's working end to end. If this returns a result, we know that OpenSearch can talk to Bedrock, and we've set up everything successfully so far. The second connector is for generating the embeddings that we talked about earlier. So that's the set of numbers that exist in that vector space. We use Amazon Titan Embed Text, which produces 1024 dimensional vectors. It's the model that turns the text into those meaning fingerprints. It's used both at index time, when your content is embedded and indexed, and also at query time to process and understand the user's query. Very similar to before, we just deploy this one. And this is where everything starts to come together in terms of how the actual search works, the search pipeline. The search pipeline has two parts. First, it has the normalization processor for hybrid search. We set up hybrid search to combine keywords, so the old type of search, along with the semantic search with a 70-30 weighting favoring semantic search. This means when your scoring is running, you will still get some of that scoring juice from keywords. They're not completely ignored. And it means you can still do things like boosting. And then the second is the RAG response, which is the Google AI type of thing that we looked at. It takes the top results and feeds them into the LLM with our prompt and generates the summarized answer. The user instructions defines the prompt, and this is the tone and how you want the LLM to respond. With the context size at the bottom there, oh, actually, no, sorry, that's next. This is the context. And this is where everything kind of wraps up. It's the search itself that's being run. For most of our sites, this is a decoupled approach, so we'll tend to have some JavaScript that runs the search. But there's also a couple of really good modules that you can just install on your Drupal site. Just because I haven't actually talked too much about Drupal itself, I probably should. There's the Search API Semantic, Search API OpenSearch Semantic, it's a mouthful, and then the Search API Semantic AI module, I believe it's called. And those two things will mean you don't need like a decoupled JavaScript approach. They'll just run it with you in views if you're still doing things that way. You kind of get to have either choice. But this is what the query looks like. So the hybrid search is running a neural query. Neural is the semantic, and then a match query, which is the keyword. And it runs it against the same fields or the same set of fields. The neural query finds the semantically similar content. The match query contains the exact keyword hits. And then the normalization processor blends those two scores together based on your weighting. The generative QA parameters part, it tells the RAG processor to use the top 5 results as context when it's generating that summary. The user gets back the results and the generated summary. And I just wanted to call out that context size. So we've found that 5 is a good mix between latency and cost and accuracy. If you needed very specific results, you could feed 10 to 15 results there instead as context, but it's going to be a bit more, take more time to run because it's just processing more information, and it will potentially have a bit more cost, which I'll come to later. And just because that was a whole lot of code that all of you very patiently sat through, I appreciate it. I just wanted to show the whole thing together in one slide. This is the full pipeline from the user's query to the final answer. And this kind of shows how all the different components interact together, starting from the user's query, passing through to OpenSearch, and then passing back to the user. And before we finish, there was just a couple of caveats to keep in mind, because not everything can always be perfect. There's always got to be something. The first is cost. So in something like this, like semantic search with RAG processor, you're passing information back between two separate models. So you're passing through a model that generates the embedding, and then that is then passing to another model that generates the RAG response. When you've got external services like Bedrock, it means it's incurring costs per request. So it's important to monitor usage and set guardrails to prevent costs just running away if you have a high traffic event or someone wants to be a bit more nefarious with your site and try and like ramp your costs up. So potentially one thing you could do would be to have something like a feature flag on your website or a pricing endpoint, and when a price hits a certain amount that you're comfortable with, feature flag triggers and it turns off the RAG. Semantic search itself isn't very expensive. Like we're talking about the hundreds and hundreds of cents type of thing, but the RAG is a bit more expensive. So if you did want to think about where to save costs from running away, that would be the thing to turn off and just be cautious about. And the second is latency. In our testing, it's not significant, but because you are passing things through so many different models, it does take a bit longer than just running a search that's just pinging your search and returning results straight back. In most cases, it's acceptable, but if you need instant results or you're finding things are taking a really long time with your hosting infrastructure, it could be something worth considering. It's kind of a trade-off between the richer answers and the speed. Potentially what you could do would be to return the results immediately and then lazy load in the RAG response afterwards so the user's not actually waiting. It would probably mean you need to run it as two separate queries, but the performance would be a lot better and it would be essentially like unnoticeable by the user in most cases. So just to wrap everything up, keyword search has been really fantastic and has served us really well for the exact matches. But as things with AI and everything is moving forward and users are kind of asking different questions, it's kind of started to fall apart. Semantic search closes that gap by actually understanding the meaning behind what a user's asking for, not just the exact words. And then taking that a step further, a hybrid search combines the best of both worlds. That gives you the keyword boosting and also the meaning behind it. And then RAG gives you that really good summary of the data itself. And OpenSearch and Bedrock, they give you all the tools to build this today. All of what I've demoed today has been built on Skipper, which is our hosting platform. It's just launched in New Zealand, so if you have any questions about hosting or this AI stuff, just come talk to me or the team. And we're also hiring if you're interested in playing around with some of this stuff. Thanks, everyone. I think we've got a few minutes for questions.
Thanks heaps, Daniel. Josh.
Hello. Is there, you mentioned like AI and LLM. So I'm not really in the know, but are there ways to run like a light version of the AI or LLM engine on your web server directly, like a Docker container or something? Or do you have to connect it to an external service and pay the extra cost for tokens?
So I imagine, I haven't played around too much with the local model side of things, but you can set up things like Olama, I think, which kind of is those local models that you can run. I don't know how well they integrate with semantic search. It's kind of, at least at the time, a new feature and it was decently tied to Bedrock. That being said, I imagine it would be possible. It would just be, not something I've tested too much or looked into. But yeah, especially as things grow and these things develop a bit further, I'm sure local models will become more feasible for those cost reasons. Exactly, it's something you can manage yourself. Yes. When you run I don't run local models on my machine just because it's a decent machine, but it's not powerful enough. But if you've got a gaming PC or something sitting in your corner not doing anything, you can maybe turn that into a little AI provider.
I saw that you had used Elasticsearch as kind of the back-end part. Can that be swapped out with like Solr or does that kind of layer become redundant?
So we use OpenSearch, which is it's like the Elasticsearch fork when Elasticsearch kind of messed around with its licensing. The semantic stuff that I've demoed is all built into OpenSearch itself. With how AI is exploding and everyone's trying to kind of get involved, I'm sure Solr has or is building an integration, right. But everything that I've done has always been with OpenSearch, so yeah, I'm not too sure about the Solr side of things, but I bet they'd be looking.
Yeah, thank you, great talk. Just a quick question, how you get the data over into OpenSearch. Like, are you using like a search API connector for that, or are you guys doing that custom to actually get the information in?
Yeah, I probably should have talked a bit more about Drupal at DrupalSouth, but we are doing search API. Yeah, that search API semantic module handles the indexing. It just gives a new search API field plugin or whatever they're called to index in that semantic style, and then the running the searches itself is just a developed solution that we built because it's all decoupled JavaScript basically. But the indexing itself, is run through Search API and Search API OpenSearch.
Great, and just one more question. When the model is sort of joining the two results, one for the keywords, the other one for the semantic side of things. I imagine when you're scoring the chunks coming back, you're sort of comparing a score on an individual chunk with an individual page. Is that Or how is that sort of normalization process done, given that you're sort of querying different things, like the keywords will be doing a page and the chunks will be...
It's always a hard question just because OpenSearch does a lot of that stuff kind of hidden from how things are actually working, and then when you put AI in the middle there too, like the exact processes are a bit difficult.
Right, so OpenSearch is doing that whole process there for you.
Correct, yeah. So we're, like in our case in here, we defined 70% comes from Semantic, which is the AI, 70% of the score, I should say, comes from the Semantic AI stuff, and then the 30% comes from just exact keyword matching, which is a bit easier to understand, I suppose, and a bit more clear, whereas the AI stuff is all about how things work and fit in the vector space and starts to get very complex very quickly. But
cool, thank you.
Well, all I'll say is we've seen results are much better, especially with long-form queries. With Semantic, it just gives it a bit more understanding in the middle.
Thanks heaps, Daniel.
Thank you.
Cheers.